Hi friends, the next topic in the second module is to look at how the data is cleaned. So when we have data, it's not necessary that the data available is in the perfect form. There may be many flaws in the data collected. So one of the important problem to look after is the missing data. Now we need to handle this missing data. So while doing that, we need to handle, identify, and address the missing values either through imputation or through deletion or other appropriate methods. If the whole row is missing, the data in the most of the cells in a row, if they are missing, the whole data can be removed or deleted, or some of the columns, most of the data in any column are missing, then that column may be neglected. But if it is now and then missing, then we neither can remove the row nor can remove the column. Then we need to do some additional work, like depending on the data, its importance, we need to handle the missing data. So one of them is to fill the gaps. Whatever is missing, we need to fill it. So depending on the data type, if it is a continuous data, then we can take the mean of the the mean of the remaining data which are available and fill all the blanks, or we can take a median, or if it is a categorical, then we can use mode of that. So various techniques are available, so depending on the situation we should use them. So we should be able to justify how this handling is done for any missing data. The next problem is outlier detection. So when we are collecting the data, it's not necessary that every data we get is perfect. So some data may be noisy, and because of that, the data values may be too much away from the reality. In such cases, it becomes easier for us to remove such data. So identify the outliers that may indicate errors or anomalies in the data. So we need to decide whether to remove, transform, or how to handle these outliers. So various techniques are there for handling these outliers. So depending on the situation, we should be able to use the appropriate method and justify them. Then comes the data transformation. So the data whatever is available may not be directly useful for our purpose. In such cases, we need to transform. Some cases the variance is too high. In such cases, it's better to work on the logarithmic world. Like if the data is uh, varying, some part of the data is varying at a micro level and some part of the data is varying at a macro level, then so if you look at the whole detail in micro level, then the whole data is uh, almost infinite in size. If you look at the macro level, then these micro variations will be neglected. Can't make out that there are micro variations in the data. So in case we want to have uniformity in both the cases, the best option is to go for normal normalization through log transformation like things. So here we stabilize the variances or convert non-normal distributions into normal distributions and so on. Then we have feature engineering. Here we create derived features. So the data available, the parameters available in the data may not be reflecting the information what we are intended to. So in such cases we need to transform the features and produce new features. So that's creating derived features out of the available parameters. So we need to generate new features, and these new features can provide additional insights or capture more relevant patterns in the data. So that's required some time. And another activity we can take up is binning. Here the continuous variables are grouped into bins to simplify the analysis or to handle nonlinear relationships. So instead of working on continuous data as it is, we can convert that into discrete version through this binning. Then what we have is exploring the data. So when you are talking about data exploration, there are many ways we can do it. So one way is univariate analysis, where from the given data, individual variables in isolation are analyzed to understand their distributions and characteristics. Here at a time, so the data may contain many parameters, but we don't use all parameters together. At any given time, only one parameter will be analyzed to understand its behavior and its characteristics and all. Then comes another version, that is bivariate analysis. Here we explore relationship between pairs of variables to uncover the patterns and potential associations. Yeah, as we discussed in some case earlier. So we can analyze the patterns or association among a pair of variables. So if the variable is one from the input side and one from the output side, then this association will tell whether the output or the input has any contribution for deciding the output or not. So if there is any association found, then we can retain this input for further activities, for further analysis and further design purpose. And if we don't find any relation between the output and the given input, then such input we can say that is no way contributing to the output. So we can remove that because it becomes a redundant parameter, and it's going to increase our cost of computation in space as well as time. So that's one advantage of working by variate analysis. Another advantage is if the both the variables of the pair are from the input side, then if we find any correlation, that means that both are somehow related to one another, and having two parameters as input which are dependent on each other is again an extra burden to the computation and analysis. Hence, one of them can be eliminated from our data set and thereby simplifying the data set and hence the analysis. Then comes multivariate analysis. Here we investigate interaction between three or more variables to gain a more comprehensive understanding of the data. So first we start with univariate. Individually each parameter is analyzed, then pairs of parameters are analyzed, and then from the remaining parameters multivariate analysis can be taken up and try to correlate the output input relationship. Then comes a pattern recognition. Here it is used to identify the trends and patterns between the variables, input variable, output variable, or within the variables. So once this trend and pattern is identified, then it becomes easier for analyzing. Then we can look for clustering. So here the algorithms are used to identify natural groupings or segments within the data, and once this segmentation is done, then for each segment a different methodology may be applied, or a better insight is available after this grouping, so that makes next further analysis easier. Then what is more important is communication. So that's reporting and documentation. So we need to communicate the findings, insights, and potential challenges discovered during this EDA process. So the document is the steps taken and decisions made during the analysis. All the steps taken and the decisions made during the analysis are properly documented and communicated among the stakeholders, so that makes the process more transparent, and the whole overall process efficiency will improve if proper communication is established among the stakeholders. Then we have some tools for the EDA, like programming libraries we have. So here we utilize the programming libraries and languages such as Python, and the libraries like Pandas, NumPy, Matplotlib, Seaborn, or for language R we use for more efficient and customizable EDA. Then we would like to use some graphical user interfaces tools like Tableau, Power BI, Excel, used for interactive and visually appealing exploratory data analysis. So that's a data science process. So here the data is collected from the real world, that is a raw data, and this data is processed and then cleaned and then fed to the exploratory data analysis. The outcome of the analysis is fed to the machine learning or statistical models to learn, and this is used to build the data product. And the data is the cleaned data is also sent to another module for communicating, visualizing, and reporting. So that's overall the data science process. Here the raw data is collected from the world, and that is processed, cleaned, and sent to the exploratory data analysis. This clean data along with the analyzed information is sent to the machine learning algorithm to create the statistical model. This statistical model is sent back to the real world for further predictions and all. And this model along with the clean data is communicated to the stakeholders and used for visualizations and reports, and final decisions are sent back to the client. So what are the roles a data scientist plays? So the it comes from the real world. The problem is from the real world. So we'll ask the question, what data needs to be recorded or collected? So here the data comes from human being, biology, finance, internet, medicine, sociology, Olympics, and many such data are available. And we formulate the hypothesis and collect the raw data. The raw data is collected either through emails, logs, medical records, surveys, blood drawn, Olympic records, and other such sources. Then this is processed using pipelines, web scraping, cleaning, munging, joining, wrangling, and all that. Then the data is cleaned using to clean the data, identify outliers and remove them, work with the missing values, debugging tables and all. And at the end, we ask the questions, what do I want it to look like, and why, what research question am I going to answer. So all these are roles played by the data scientist. Starts from the question,